Hey tech enthusiasts, are you ready for a mind-blowing revelation? Imagine typing emails, writing code, or even composing symphonies just by thinking. Sounds like a sci-fi dream, right? Well, Meta, yes, that Meta, just dropped a bombshell. They've developed technology that can translate your thoughts into text. But before you start picturing yourself as a telepathic CEO, let's pump the brakes. This tech is groundbreaking, yes, but it's also riddled with challenges. And the big question looming over it all: how far is too far when it comes to reading our minds? Stick around, because we're diving deep into the fascinating and potentially unsettling world of Meta's mind-typing technology. So, what exactly did Meta achieve? They built a brain-computer interface, or BCI, that uses a magnetoencephalography, or MEG, scanner. This isn't your everyday gadget. It's a massive piece of equipment that detects magnetic signals in the brain. The beauty of MEG is that it's non-invasive, meaning no brain surgery required. Think of it as a super-sensitive antenna picking up the electrical chatter in your brain. Now, here's where the magic happens. Meta's team, led by Jean-Remy King, fed this brain data into a deep learning system called Brain 2 QWERTY. This AI algorithm learns to associate specific brain patterns with specific keystrokes. And the results? They were able to predict keystrokes with up to 80% accuracy. That's a huge leap forward in the quest for mind-typing technology. But remember, this is still very early stages. Let's talk about Brain 2 QWERTY. This isn't just some simple algorithm. It's a sophisticated deep learning system trained on vast amounts of brain data. The researchers had volunteers type phrases inside the MEG scanner while recording their brain activity. The more data Brain 2 QWERTY processed, the better it got at deciphering the neural code for each letter. Now, deep learning, in essence, is about teaching computers to learn from data, just like humans do. It involves feeding the system massive amounts of data and letting it identify patterns and make predictions. In this case, the system learned to associate specific brain signals with the act of typing specific characters. It's like teaching a computer to read your mind, one keystroke at a time. The implications of this are enormous, potentially revolutionizing how we interact with technology. But, and this is a big but, it's far from perfect. The 80% accuracy rate means that 1 in 5 letters is still wrong. Imagine trying to write an email with that kind of error rate. Frustrating, right? Now, let's zoom in on the MEG scanner itself. Magnetoencephalography, or MEG, is a neuroimaging technique that measures brain activity by detecting the tiny magnetic fields produced by electrical currents in the brain. Unlike other brain scanning methods like fMRI, which measures blood flow, MEG directly measures neural activity, providing excellent temporal resolution, meaning it can capture changes in brain activity in real time. This is crucial for mind typing because the brain signals associated with typing are fleeting and dynamic. The MEG scanner is incredibly sensitive. It needs to be housed in a specially shielded room to block out external electromagnetic interference. The user has to remain perfectly still, and the device itself is massive and expensive, costing around $2 million and weighing about half a ton. This makes it highly impractical for everyday use. It's like trying to use a particle accelerator to send a text message. The technology is powerful, but the format is not yet ready. Okay, let's address the elephant in the room: the sheer impracticality of this technology. Imagine lugging around a half-ton MEG scanner just to type a tweet. The size, cost, and sensitivity of the device make it completely unsuitable for commercial applications at this stage. As Jean-Remy King himself admits, this isn't about creating a product anytime soon. The technology requires a shielded room, and the user needs to remain perfectly still. Even a slight head movement can throw off the signal. So, while the 80% accuracy is impressive, it's achieved under highly controlled and unrealistic conditions. This is a classic case of lab research versus real-world application. The potential is there, but the road to commercialization is long and arduous. Think of it like this: you've invented a revolutionary engine, but it's the size of a house and requires a team of engineers to operate. It's amazing, but not exactly ready for your car. But hold on. Meta isn't just throwing in the towel. They see this research as a valuable stepping stone towards advancing AI in general. Jean-Remy King believes that understanding how the brain processes language could revolutionize the next generation of AI. Language has become a foundation of AI, he stated, adding that the principles behind the brain's language formation could shape the next wave of AI technology. So, even if we don't see mind-typing headsets anytime soon, the insights gained from this research could have a profound impact on other areas of AI, like natural language processing and machine translation. It's like using Formula One racing to develop better road cars. The technology might not be directly transferable, but the knowledge gained can trickle down to improve everyday vehicles. Now, let's get to the really important stuff, the ethical implications. The idea of a tech company being able to read your thoughts is, frankly, terrifying for some. Who gets access to this data? How is it stored and protected? What safeguards are in place to prevent abuse? These are all critical questions that need to be addressed before this technology gets anywhere near the market. Remember Facebook's track record on privacy? It's not exactly stellar. The company has faced numerous scandals over data breaches and privacy violations. So, the prospect of them having access to our brain data raises serious concerns. In fact, some countries are already considering legislation to protect neuro rights, the right to mental privacy and freedom from manipulation. This is a debate we need to have, and we need to have it now. Are we willing to sacrifice our mental privacy for the sake of technological convenience? It's a question with no easy answers. So, what does the future hold for brain-computer interfaces? While Meta's project faces significant hurdles, other companies and research institutions are exploring different approaches. Some are focusing on invasive BCIs, which involve implanting electrodes directly into the brain. While these methods are more accurate, they also carry significant risks. Others are exploring less invasive techniques, like EEG, electroencephalography, which uses electrodes placed on the scalp to measure brain activity. The challenge is to find a balance between accuracy, practicality, and safety. The ultimate goal is to create a BCI that is both powerful and user-friendly, allowing us to seamlessly interact with technology using our minds. Imagine controlling your devices, communicating with others, or even accessing information, all without lifting a finger. The potential is enormous, but we need to proceed with caution, ensuring that ethical considerations are at the forefront of development. It's a journey into the unknown, but one that could transform the way we live and work. It's important to note that Meta has actually shelved its plans to create a consumer-ready brain-reading interface using optical technology. After 4 years of research and development, including funding brain surgeries and building prototype helmets, they concluded that consumer brain reading is still a long way off. Instead, they're focusing on a wrist controller for virtual reality that reads muscle signals in the arm. This decision highlights the immense challenges involved in developing non-invasive BCI technology. It's not just about the technology itself. It's also about the ethical, social, and regulatory hurdles that need to be overcome. Meta's experience serves as a cautionary tale, reminding us that even with significant resources and expertise, the path to commercializing brain-computer interfaces is fraught with obstacles. It's a marathon, not a sprint, and we need to be prepared for a long and winding road. All right, let's wrap things up. Meta's mind-typing technology is undeniably impressive, a true testament to the power of AI and neuroscience. But it's also a stark reminder of the challenges and ethical dilemmas that lie ahead. The technology is far from ready for prime time, and the privacy implications are significant. But the research itself is valuable, potentially paving the way for breakthroughs in AI and our understanding of the human brain. The future of BCI is uncertain, but one thing is clear. We need to have a serious conversation about the ethical and societal implications of this technology before it's too late. So, what do you think? Are you excited about the potential of mind-reading technology, or are you concerned about the privacy risks? Let me know in the comments below. And don't forget to like and subscribe for more deep dives into the world of AI and technology. The future is coming, and we need to be ready for it.